Section 6.5 is on difference of squares and perfect square trinomials. We've talked about these in the past. We noticed that if you have a squared minus b squared, that is the result of taking the quantity a minus b times the quantity a plus b. And so this makes difference of squares really easy to factor. So if we had x squared minus 16, we know that's x minus 4 times the quantity x plus 4, because we know the negative 4x plus the positive 4x is going to give us 0. And then if we had something a little more exotic, like 4x squared minus 25 y squared, we know that's going to be 2x minus 5y times 2x plus 5y. And we just are noticing that we have 2x quantity squared minus 5y quantity squared, and so the factorization is easy if we remember a minus b, a plus b. Once in a while we'll come across something like x cubed minus, let's make it 3x cubed minus 48x. We notice that it's not a difference of squares, but if we factor out that 3x, we're left with x squared minus 16, and so we're right back to 3x times the quantity x minus 4, quantity x plus 4 again. Similarly, we notice that if we have, well, actually one thing to notice is that x, if we have a squared plus b squared, this has no nice factorization. So we have to be careful of that. If you see x squared plus 9, we can't do anything with that. If we try doing x plus 3x minus 3, we know that that's equal to x squared minus 9, which is obviously not x squared plus 9. And we're going to talk in just a moment about if we took x plus 3 times x plus 3, remember that's going to give us x squared plus 2 times 3x plus 3 squared equals x squared plus 6x plus 9. So we get that middle term of 6x, so again, not x squared plus 9. And so in the end, x squared plus 9 is prime. We notice squaring that x plus 3 does suggest that if we have a squared plus 2ab plus b squared, 2ab plus b squared, that's going to factor as the quantity a plus b squared. And so in general what we can do is if we see that we've got an a squared, if we have a squared and b squared, we can check for a middle term of 2ab. And so if we saw something like 4x squared plus, what do we want to be, plus 12x plus 9, we notice that 4x squared is going to be 4x squared, we get 4x squared is going to be 2x quantity squared, 9 is 3 squared, and so we check, is 12x equal to 2 times 2x times 3? 2 times 2x times 3, and the answer is yes. 2 times 2x is 4x, 4x times 3 is 12x, and so we know this has to factor as 2x plus 3 times quantity squared. And so those sums of those perfect square trinomials are, again, they're not as easy to factor as difference of squares, they're not as obvious, but they're still pretty straightforward. If we have the a term and the b term, or sorry, the a term and the c term are both perfect squares, it's worth checking. So you notice that if we had x squared plus 8x plus 16, we notice that the x squared is obviously an x squared, the 16 is obviously 4 squared, and so we just check 2 times x times 4 is 8x, and so we know that has to be the quantity x plus 4 squared. You notice if we had had x squared plus 10x plus 16, we still have x squared and 4 squared, but now we notice 10x is not equal to 8x, and so this is not a perfect square trinomial. Sometimes we can factor them anyway. We notice in this case we could factor it as x plus 2 times the quantity x plus 8, but we notice not a perfect square. So let's try a few examples. If we look at 9x squared minus y squared, that's an easy one. We notice that's going to be 3x quantity squared minus y squared, and so we know that has to be 3x minus y times the quantity 3x plus y. If we tried, that's a fun one, if we tried looking at 28 minus 7h squared, we notice that this is not a difference of squares, but if we factor out a 7, we get 4 minus h squared, and that becomes 7 times the quantity 2 minus h times the quantity 2 plus h. And so we notice that once we do the initial factorization, we get a difference of squares. If we had x squared plus 18x plus 81, we know that's going to be x plus 9 quantity squared, because we have x squared, 9 squared, and 2 times x times 9 is 18x. And so we notice that our perfect square trinomial factorization winds up working. Again, we have to watch out for our order. We notice that if we looked at 4 plus z squared minus 4z, this is not in the correct order for factorization. We first have to look at it as z squared minus 4z plus 4, and then we notice that's going to be z squared, 2 squared, and then we're going to have 2 times z times negative 2, and so we're going to get z minus 2 quantity squared. So notice we have to be careful of that sign. We notice that if we had taken z plus 2 quantity squared, that would have given us z squared plus 4z plus 4. So we have to be careful whether we use a positive sign or a negative sign. It gives us slightly different polynomials.